Okay, I'm making this video for the benefit of my students. We are currently learning about fractions, and yesterday we did a lesson about fraction inequalities. And I had a few students who may have issues, and I was thinking about trying this new program to record videos where I demonstrate how to work out some math problems so students can get help when they're at home by coming to my YouTube account. One of the ways that students can figure out if fractions are equal or not is to look for benchmarks. Look for benchmarks. When I talk about benchmarks, I mean 0 is a benchmark. 1/2 would be a benchmark. A whole would be a benchmark. And if I had a number line that had these on it, if I were to put any fraction on there, as long as it's just a fraction, not a mixed number, then I could put it close to 0, or close to half, or close to whole. And that would give me a good idea if one fraction was greater than the other. For instance, if I had, let's say, 2 over 10. If I had 2 over 10, that is very, very close to 0. That would probably pop up right about here. And so I know its benchmark is about 0. And if I were having to compare that with another fraction, say 12 over 13, that 12 over 13, if I were to plot it on a number line, it would be very close to the whole. It would probably be maybe somewhere around here. Now, these are not drawn to scale, but at least it gives you an indication of where they would be closest to on a number line. And in this case, it's obvious that 2/10 is less than 12/13. So there I go. So benchmarks are one way that you can figure out if one fraction is greater than another. Another example of a benchmark fraction, I'm going to try this one. Let's say that I had, I don't know, we'll say 6 over 13. And then I had maybe, let's say 7 over 12. Now, here you have two fractions that are very close to half. For instance, 6 over 13 would be very close to half, and 7 over 12 would be close to half. The thing is, though, for 6 to be a numerator with a fraction equivalent to half, this would have to be 12. But since it's 13 and not 12, then this is just a little bit shy of half. So that would actually be right around here, we'll say. Once again, not drawn to scale. And this 7/12, well, for 7 to be a numerator on a fraction that would be equivalent to half, this would have to be a 14. But because it's a 12, this is actually a little bit more than half. So I could put this one over here. So by doing it that way, even though they're both very close to half, we know that 6/13 is just a little bit less than half, therefore it is less than 7/12. So that is one way of figuring out if fractions, if one is greater than the other, is by working with benchmarks. Now let me clear my screen. Okay, and let me scroll on down. Another way that we can do this would be by looking at unit fraction rules. Unit fractions are those fractions that have 1 as the numerator, and then the denominator can be anything. Now, for people who are new to doing fractions, when they look at this, they might think that 20 is a much bigger number than 10, therefore this has a greater value, but no, it doesn't. Because this is 1/20th, it is a smaller value than 1/10. It would be like if you had a video game and you had to share time with 20 people. There were 20 of you sharing time playing a video game. Your time would be a lot less than a group where you only had 10 people sharing it. So even though this is a bigger number, the value of the fraction is a whole lot less because there are a whole lot more possible parts than the whole. So in this situation, 1/10 would be greater than 1/20th. When you're working with unit fractions, anytime you have a big denominator, it's going to be a smaller value than the other fraction that may not have as big a denominator. Now, another kind of rule close to this would be if you had a situation where you had perhaps the same numerator, like maybe 3 over, we'll say 5 in this case, and 3 over 7. Well, even though it's a little bit different, here we had 1, because we have the same numerators here, we know that this is going to be greater regardless, because 5 is a smaller amount to share among the wholes, and 7, this is going to have a greater value. So 3/5 would be greater than 3/7. All right, there's another way. Let me clear this and scroll on down. Another way could be to make a model. Now here, this model, it is for a fraction like 6/15, and this fraction would represent 2/5. And because I made a model, it's easy to see that they're equal. They're equal. Here we have 1, 2, 3, 4, 5, 6 parts of the 15, and here we have 2 parts of the 5, and because they both are flush here, they're equal. Now, the way that I made this model, I'll show it right now in case I have students who have this program on their computer and they want to be able to make a little model. One of the things that I did is I always go to Insert, Table, and I'm going to give it 2. I'm going to give it two bars. Now I want to make this a lot bigger, just because it needs to be bigger. So I made this bigger, and now what I have to do, like if I had a fraction, let me clear my board completely. If I had a fraction, for instance here, that we'll make this one be, how about 8/11? 8. This is my first time working on this, so please bear with me. So if I want this one to be 8/11, and then this one, I'm going to let it be 2/5. No, we've already had 2/5. I'm going to make it be 2/4. Now, I know that will reduce down to 1/2, but just for demonstration purposes, I'll just leave it 2/4. Now, what I would do then is I'd click inside with a right click on my mouse, and then I'm going to say split cells, and I want to have 11 of those parts. So here now I have 11 parts, and here I need to have 4 parts. So I'm going to go split cells, and I'm going to say 4, and I'm going to hit OK. Now this one I need 8 of these. So 1, 2, 3, 4, 5, 6, 7, 8, and I'm going to shade those like that. Now here I need 2/4. So 1, 2, and I'm going to come up here to shade, and I'm going to do that. And here it's obvious that 8/11 is greater because you've got all this part here that's greater. So 8/11 would be greater than 2/4. So a model would be one way that you could do that. Now let me clear my board. And then there is one last way that I'm going to show, and that's going to be coming up with like denominators. So that would be like denominators. And with like denominators, it's good if you have a good idea, good knowledge of how to come up with a least common multiple. Let's say that I have, in this situation, let's say that I have fractions, let's see, 8/10, and I have 3/5. Well, my least common multiple of 10 and 5 is 10. So I would just have 10, and 8 stays the same because 10 times 1 is 10, 8 times 1 is 8. And here, 5, I'm going to make it 10. I had to multiply 5 by 2, and so 3 times 2 gives me 6, and 8/10 is greater than 6. Now, I want to keep this under 10 minutes, so I'm going to leave that like that. And I hope that my video was more help than confusing. Thank you.